Hello, everybody. Today we're going to be talking about data sizes and how they could be stored in memory using valid location. So to begin, we have a char that is 1 byte, a short that is 2 bytes, and an integer that is 4 bytes. And the memory is 4 bytes wide and can be accessed one line at a time. And every byte has an address in the memory. So when we're working in the memory, we're going to start at address 100 and we're going to move on until we have enough where we could store everything that we need to. So going to the next slide. We have a char, again, like I said, is 1 byte. And because there's only 1 byte, any address in the memory we could use to have that char be stored. So in this example here, I have char A through F, and as you can see in the image below, every address in the memory is blue, which means that it's okay and okay to be used for the char. So for A, it could be stored in address 100, which is 1 byte, B 101, 1 byte, C 102, and that is 1 byte as well, and so on for the rest of them. And we don't need address 106 and 107 because we only have 6 chars and each char is only 1 byte. It can be used anywhere inside the memory. So now to move on to short, it is 2 bytes. And the only places it could be stored in memory are addresses with even numbers and multiples of 2. So for an example, in this image, I have short A, B, C, and D. So for short A, it is purple, which means that it's okay to be used as it's going to begin in address 100, which is an even number. So A is 2 bytes long, and it's 100, and it takes over 100, address 100, and address 101. And we go on to the next line. We're going to try and have it be stored using the second spot inside the memory. So we have it being started at 105, but because there's not an even number, we cannot use that to have the short be stored. So as you can see, 105 and 106 are both red. So move on down to the third spot in the memory over, which is 110. And because that is an even number, the short can be put there and it's purple. So going to the last one, the fourth spot is the odd number, 115. So it's red and cannot be used there. And just to point something out, say we weren't doing this example and we're given an actual problem to have short A and short B be stored, we could have short A be stored in the first two, 100 and 101. Then we could store short B in the second two, which is 102 and 103. So we don't have to wait and go down to the third line over here. I'm just showing this so you guys can see where to start when you're having a short. So now I move on to an integer, which is 4 bytes. So valid addresses are multiples of 4. And so for example, I have A, B, C, and D. And in this example, we're doing the same thing as we did in the last example with the short. So first we're going to start off in address 100, and that takes up 4. So, and because you're starting in 100, you have 3 more spots to cover, which then 3 plus 1 is 4. So that's good to be used here. But now we're starting in 105, which is not a multiple of 4. So that's red. Now we're going to start in 110 in the third spot, not a multiple of 4, so that can't be used. Then start in the last spot, 115, again, not a multiple of 4, and also cannot be used. So now I'm going to go over a full example that you might see on the homework or an exam. So fill in the memory using valid location and do not optimize. And when it's saying do not optimize, it just means to go in order and don't reorder any of these to try and save spaces. So we're doing char with an array, char A with an array of 3, short B, array of 3, integer C, integer D, char E, short F, short G, and integer H. So to begin, we start with the first one, char A with an array of 3. And again, if you go back to the first slide, we see char is 1 byte and any address is valid. So we could see here, char A, an array is 0, because again, arrays start at the number 0. We have address 100, blue, which is okay to be used. Then we've gone to array 1, stored in address 101, again valid. And then A, array 2, address 102, again valid. So we have 1, 2, and 3 char. So this one is all set. And now we move on to short B with an array of 3. And as you can see here, we don't use address 103, because if you go back to the short slide, it says valid addresses are even and then multiples of 2. And as you can see, address 103 is not even and not multiple of 2. So we're going to skip address 103 and move on to address 104, which is, so we start off with short B array 0. That takes up 2 spots. 1 and 2, address 104, address 105. And now we're going to move on to B array 1. Again, takes up 2 spots, 106 and 107. And then we move on to B array 2, which takes up 2 spots, address 8 and 109. And we don't have to leave anything blank in between these shorts because they both start at multiples of 2. So 104 multiple of 2, 106 multiple of 2, and 108 multiple of 2. So now we have the short B array 3 done. And we can move on to integer C. And if we go back to the integer slide, we're going to see that integer is 4 bytes and the valid addresses are multiples of 4. So we're going to skip 110 and 111 because 110 is not a multiple of 4. So go on that down to 112, which is a multiple of 4. So we're going to use this whole row for integer C. Then we're going to, so integer C is done. Go down to integer D. So now we have this whole row done. We go down to address 116, which again is a multiple of 4. So we could put integer D here. So this whole row is done. And now we're back to char E. And if you guys know what char is, it's a address, or it's a byte of 1. So we could store it right here, right after the integer and address 120. And now short F is bytes of 2. So we can't use it here because the short has to be even addresses. So we go down to address 122 to do the short, which is 2 bytes, takes up address 122 and 123. And after that, we have short G, same thing, has to be an even address and a multiple of 2. So we could do right after short F, going down to address 124, and we could put short G here. So now we have short F and short G done. And now we move on to integer H, which is again, if we go back to the integer side, bytes of 4 and valid addresses are multiples of 4. So we can't use address 126 or 127 as they aren't multiples of 4. So we go down to address 128, which is a multiple of 4, and we do integer H for bytes across, and that is a problem. Hopefully this helped you guys. Thank you.